Hey guys, let's talk about doing a detailed diagnosis of a screen of death. Thanks for joining me. I'm Canooga Combs, a lifetime bike enthusiast. I like to ride them and I like to work on them. Let's get into the heart of the video here today. In my earlier video in this series, I explained the most likely reasons for the problem and the potential fixes. However, because those fixes did not work, I had to further diagnose the problem. And this video is going to show the detailed steps in my diagnosis. Before we go any further here, a word of caution. When you're dealing with these batteries and the connection to the batteries, you're dealing with some very high voltages. And please do not try these procedures unless you have the appropriate electrical experience. Just to highlight, first of all, the battery is high voltage and there's a risk of shock and a risk of arcing, electrical arcing. I've shown in the far left here, number one, the tag on the battery, and it shows that it's a 48-volt battery. That's high voltage, and you just want to make sure that when you're dealing with the copper cups and the female battery connector pin slots on that battery, that you're very aware of that, and certainly don't stick anything in there that could cause arcing or could shock you. The other thing to be aware of, and a big dose of caution, is the motor capacitor. Even when there's no battery in that bike, there's high voltage and a risk of shock and a risk of arcing. I've shown in picture number 2 here where I've actually connected up alligator clips to the male battery connecting pins, even though the battery is not in the bike. And as you can see in number 3, that even without the battery in the bike, it's still registering 42.9 volts on my multimeter. So, you just want to be very, very careful in dealing, with these battery and battery connectors, even when the battery's not in the bike, because, there is high voltage involved and there's a risk of getting shocked or a risk of electrical arcing. So just proceed ahead with a great deal of caution here. Basically, there are 4 reasons and tests for the screen of death. The first is that the battery is defective, and you can test that by testing the voltage in the battery. The second is that the BMS switch is defective, and you can test that by testing the continuity of the switch. The third is that the motor is defective, and you can prove the motor is not defective if you can turn the motor on. If none of these 3 things are defective, then the issue most likely is in the connections. Also, before we go further in this analysis, I want to just make sure we're all straight on the nomenclature. This is the end of a battery, and in the red lettering, and I've drawn a circle around them in yellow, these are the copper cups, and these are the cleanliness of these copper cups is critical to making sure that the bike will perform properly. Also on the end of the battery are the female battery connector pin slots, and I've identified those with blue lettering and blue arrows. The first 2 of those are negative, and the second 2 are positive, and that just gives you an indication of how to hook up your multimeter here based on the positive and negatives. Now, to do the battery test, this is how not to test the voltage. It would appear that you would just take the multimeter, set the multimeter to the appropriate places, and then insert the pins into the positive and negative positions, and you would get a reading. However, the reading on a 48-volt battery at 12.3 is meaningless, and this is not the way to test the voltage. This is how you test the voltage on the Dengfu e10 battery. First, you need a piece of copper wire, and that copper wire needs to be bent into a U, and the U would be so that the ends of the U would fit into the copper cups on the battery. In step 2, I'm showing an insertion of the copper U into the copper cups, and I'm also showing that I've stuck straight pins into the female battery connector pin slots, and I've attached alligator clips to those pins. In picture 3, you can see I've connected the other end of the alligator clips to my multimeter, and as you can see circled in orange, the reading on the multimeter is 51.8. Now, 51.8 is greater than 48 volts, but depending on the percentage of charge on the battery, a 48 volt battery will read between the low 40s and the low 50s. This battery was about 90% charged, so the 51.8 is an appropriate reading, and I would determine based on this test that the battery is not defective. The next test is testing the BMS switch, and if you look inside the bike where the battery attaches to the bike, there are some male BMS switch receptors, and I've highlighted those in red with the name in red, and I've drawn a yellow arrow to those 2 switch receptors, and they're critical in this test, and they're just above the male battery connector pins. But in this test, we're going to focus on the BMS switch receptors. And by the way, it's very easy for these BMS switch receptor pins to become corroded or to not work properly. We'll talk more about that later. But to test the BMS switch, this is a continuity test. And as picture 1, I've attached the alligator clips to the male BMS switch receptors. And then in step 2, I've attached those alligator clips to the ends of my multimeter. And in step 3, I've mounted the multimeter with a piece of Velcro so that it's right beside the BMS switch on the bike. Now, the multimeter is reading 1, and on my multimeter, when there's a 1 and you have the multimeter set to do a continuity test, a 1 means that there is not a continuous source or not a continuous line between the positive and negative. In other words, there's an interruption in the movement of electricity between the positive and the negative. When I match the switch button, though, the reading changes from 1, and in this case, it changes to 0.0, as you see in picture 4. Now, the fact that it changes from 1 to some random number means that once the switch is engaged, there's a continuous line, and because the continuity test indicates that there is continuity, you can conclude that the BMS switch is working properly. So the BMS switch is not the problem here. The next is motor activation, and this is a much harder thing to do. We basically have to determine if the motor will come on once it has a power source. And in this particular case, the way I did that, I partially inserted the battery in the bike, as you can see in picture 1. And what I'm doing here is by partially inserting the battery, the contacts are going to hit or come together at different places, and they may be able to provide power from that battery. Whereas if the battery was fully inserted, we know that it won't work. But by partially inserting the battery, it may cause the connections to hit in a different way so that they would provide power. And so I inserted the battery, then I mashed in the BMS switch. Then in number 3, I mashed the button to turn on the motor based on the controller on the bike. And in step 4, the motor actually powered up. So the motor will activate when power is provided, and therefore we can conclude that the motor is okay. So based on these tests, the battery's okay, the BMS switch is okay, the motor's okay, and we can most likely assume that the connection is not working properly, meaning that the copper cups and or the male BMS switch receptors are corroded. This would mean that my earlier cleaning of these was probably not adequate. So in my next video, which will be video 3 in this series of 4, I'm going to show how these contacts are more thoroughly cleaned. And part 3 or video 3 of this series is what I call the standard fix. And this would be the way that you would typically fix this problem based on the information that I now have from doing the detailed diagnosis. So I hope I've given you guys something to think about, and I'll see you at the top.